And just a quick one to sort of talk about electric fields before we so I've got this electric field that just sort of goes like this. And what I'm going to do is I'm going to dump a proton in here, and I'm going to drop an electron in here, and I'm going to see what happens. Well, the first thing I'm going to do is I'm going to have a little race. Well, the first thing I'm going to notice is that my proton is going to race which way? Well, what we have to know is we have to know that okay, I do know. The protons are going to go that way, and the electrons are going to go that way. We'll talk about that in a later video. Now, what I know is that the Q for a proton is equal to the Q for an electron. So if I dump them into the same electric field, I know that the force on the proton is going to be equal to the force on the electron. Well, I should put an equal and opposite there. So I'm going to put an equal and opposite. So they're going to have the same force. Now I've got this equation, work equals force times distance. And so what I'm going to do is I'm going to set up, I'm going to say this is 10 centimeters, and say this is 10 centimeters. And what do I know about them after they've traveled 10 centimeters? Well, if distance 1 and distance 2, if distance 1 is equal to distance 2, well, let's keep proton and electron. That's proton, that's electron. If the distance for the proton is equal to the distance for the electron, then I know that the work done on the proton is equal to the work done on the electron. And they started from rest, and so I'm going to know that the kinetic energy of the proton is equal to the kinetic energy of the electron. They're going to have equal kinetic energies after they've traveled the same distance. And then the last thing, I'm just sort of throwing some things out there. Suppose I actually measure time. So let's say that my time for the proton is equal to time for the electron. Then I'm going to say that force equals change in momentum over change in time. And so if they both have the same force and they both have the same time, then force times time equals change in momentum. So if they have the same time, I'm going to say that the momentum of the proton is equal to the momentum of the electron. Now, of course, what's going to happen is, because the proton is so much heavier, it's going to take a lot more time to go this distance than this one. And so what's going to happen is the electron is just going to shoot away. And then the proton is going to go doop-de-doop-de-doop-de-doo and sort of work its way to the right. Okay, but some interesting things just to think about in terms of some equations, work and impulse, is that after they've traveled the same distance, they're going to have the same kinetic energy, and after they've traveled for the same amount of time, they're going to have the same momentum. That's kind of just an advanced topic that I just threw in there.